Hello, it's Mr. Cruz. This is a short video on static electricity, and in a moment I'm going to ask you to press pause. I want you to go get a sheet of paper and a pencil because there's going to be a short quiz, 4 questions that you're going to have to turn in when the video is over for homework. So go ahead and hit pause and do that, please. Welcome back. Here we are with a picture of an atom, and you can see here that it shows all the parts, and I want you to think about which of these 3 parts, the protons, neutrons, or electrons, which of those 3 particles do you think would be involved with electricity? The particles that would be most easily lost or gained would be the answer. So take a guess. If you guessed electrons, you are correct. Electrons are deeply involved in electricity. Let's go to the next slide. So you can see here that electricity is energy caused by the flow of electrons. And here the key word is flow. When electrons are moving, that is electricity. But we're going to learn about static electricity today, and that is the buildup of electrons on an object. We've all experienced static electricity, maybe with our hair, or going down a slide, feeling a shock on a doorknob. Those are all a result of static electricity, when electrons build up on an object. The word static means still, not moving. So when electricity doesn't move and it just builds up electrons, that's static electricity. Now, one quick and easy concept is understanding how electric charges interact with each other. You can see here that we have 2 positively charged objects that are hanging from a string. And notice that they're pushing away from each other. That means that they're repelling each other. And these charges are the same. 2 positive charges repel each other, just as 2 negative charges repel each other. So we use the term like charges repel. If the charges are the same, then they repel each other. And then, of course, the good old cliche, opposite charges attract to each other. So if an object is positively charged and it's close to another object that's positively charged, they will push away from each other. If 2 opposite charges are close to each other, they will want to stick together. They're attracted to each other. Now there's 3 ways that charges can build up on an object. There's 3 ways that we can create static electricity or move electrons around. One is friction, and this is very common. Rubbing a balloon on your hair transfers electrons from your hair onto the balloon, and the balloon would become negatively charged. That's by rubbing them off, basically, because remember, the electrons are loosely held in the atom. And so rubbing your feet on the carpet is friction. Clothes tumbling around in the dryer, rubbing against each other, become charged by friction. And those are some common examples that you're probably familiar with. The second way that charges can transfer is by conduction, and that just means that they're touching each other. So in this example, we have a ruler that has a negative charge, and if you simply touched it to a metal rod, all those charges would flow onto the metal rod, and then the metal rod would become charged. So that's charging by conduction. The third way is induction, and that's when an object becomes charged by just getting very close to another object that's charged. Now I'm going to do this in class with a balloon. If we can charge up a balloon by friction, I'm going to actually use someone's hair and charge up a balloon, and I put it really close to the whiteboard so that it doesn't touch the whiteboard. At first, the whiteboard is neutrally charged because it has just as many electrons as it does protons, maybe on the surface. But when I put the negatively charged balloon close to the board, remember, like charges repel. So the electrons on the board will get pushed back to the back surface of the whiteboard, and then the surface that I write on will become positively charged, and the balloon will actually stick to the wall. That's called induction, and that's charging the board, basically, by putting a charged object close to it. So friction is rubbing, conduction is touching, induction is just getting a charged object close to something. Here's another example of how a charge is transferred. we have a balloon, and right now guess its charge. It's actually neutrally charged. You can see that there are 3 electrons and 3 protons, and so it shows that there's an equal number. So it's a neutrally charged balloon. It doesn't have a positive or negative charge. But if you rub the balloon on a sweater, for example, electrons are loosely held, and they will be transferred to the balloon. And so the balloon gains electrons, and the balloon becomes negatively charged. Then, if you put the balloon close to your hair, it will create that static cling that you're familiar with, and you can see static electricity in action here, where the negatively charged particles in the balloon, the electrons, attract the positive charges on the girl's hair. Now, once an object builds up a charge, it can have a static discharge, and this means that it loses its charge really quick as the charges flow from one object to another. An example of this is rubbing your feet on the carpet and then shocking yourself by accident on a doorknob. So here's what happens. Step 1, by friction, rubbing your socks on the carpet would cause electrons to go onto your socks and in your body. So you become negatively charged. And so I'm going to draw a bunch of negative charges on here because this girl rubbed her socks on the carpet and now she has a negative charge. Then, by conduction, those charges travel all the way throughout her body, and I already sort of drew that right here. And so, if she puts her finger close to a metal object, like a car door handle or a doorknob, by induction, her negatively charged body, which includes her finger, will push the negative charges on the doorknob. The doorknob's neutral, but it will push the negative charges away and cause the surface of the doorknob to be positively charged. And then opposite charges attract, and those electrons will jump from your finger to the doorknob, creating a spark, and that's when you get shocked, and that's called a static discharge. Static discharges can be very dangerous. One way they can be dangerous is lightning. Lightning is just a giant static discharge. It's a magnified version. So what happens is the clouds build up a negative charge, and that's because of basically all the wind swirling around creates friction in the air, and so it builds up electric charges. And then what happens is by induction, the ground becomes positively charged because the clouds are negatively charged. And remember that induction rule, if the clouds, they have such a big charge and they cause the ground to become positive. And then there's a static discharge, just like the doorknob, where these electrons want to flow to the opposite charge because opposite charges attract. And that's when you get the big lightning bolt, the quick, super fast flow of electrons to discharge that static energy. So now here's the quiz. On your paper, all I want you to do is write the answers. So you can number your paper from 1 to 4, make sure your name's on it. You're going to turn this in tomorrow. And I want you to try to answer these questions. So hit pause, answer the questions. I did give you a word bank. And then after you hit play again, I will go over the answers and you can check them. Okay, let's do number 1. A buildup of an electric charge on an object is called, oops, I didn't even have it on here, static electricity. Mr. Cruz made a boo-boo. Static electricity should fit in number 1. Hopefully you caught that. Because the key word there is buildup. Buildup of electrons is static electricity for number 1. Number 2, charges that are the same blank each other. The answer should have been repel. Number 3, blank is an example of a large static discharge. Lightning is an example of a large static discharge. And number 4, clothes rubbing together in a dryer transfer electrons to create static electricity by the process of friction is number 4. So friction is number 4, lightning is number 3, repel is number 2, and static electricity is number 1. Thanks for watching. See ya.